Wise Way Learning presents the lecture number 51 to 57 under section 12. This is a complete project management free course from beginner to project manager with 19 sections of 100 lectures. Welcome to the course. Section 12 and lectures 51 to 57, the monitoring and control phase. This section includes the lectures such as, Lecture 51 What is monitoring and control? Lecture 52 What is controlling in a Prime Minister environment? Lecture 53 How to check if a project is on schedule? Lecture 54 How to see if a project is on budget? Lecture 55 How to perform quality control? Lecture 56 How to keep the risk log updated? Lecture 57 How to deal with change proposals? Section 12 and lecture number 51, What is monitoring and control?
So we have to admit we've been a little vague when it comes to measuring output. Using phrases like a good rate, high quality, and fast enough. Imagine that you ask your engineer for technical details of the construction plans and materials to be used. They reply, "We're going to use decent steel and the quality of concrete and brick is satisfactory, so the chances of the building falling down in an earthquake is small." Not only is that description vague, but it's also subjective. So what should we do about it? Well, as the famous Peter Drucker quote goes, what gets measured gets done. If you want things done the way you want them, define a metric, set a target and measure the performance. Then there is a step 4 if the actuals do not match the target. Identify the reason and take action to correct the performance. Let's look at an example. Imagine you're practicing for the 100-meter sprint at the Olympics and you have 3 months to improve your sprint speed. You need a way to measure if you are improving, right? How about seconds from start to finish? Great, I think that's your metric. Now let's say you want to improve by 20%. Currently you run at 15 seconds, so if you break it down month by month, after month 1 you want to be running at under 14 seconds, month 2 under 13 seconds, and month 3 under 12 seconds. That is your target. And now you have to have a plan. You go out every Tuesday and have your friend time you and record it. That's what we call the actual. So here we have our example. You can see in month 1 your progress was good. However, by month 2 it seems to slow down. This means that you now have the chance to adjust your 3rd month's target or change something about the way you train so you can hit the target. If you were not measuring your progress like this and just relied on being fast enough, you wouldn't qualify for the Olympics. I hope this gave you an idea of the purpose of monitoring and control activities, because now we're going to go into it in more detail in a project manager environment. Thanks for watching.
Section 12 and lecture number 52, What is controlling in a project management environment?
Yet again, we've got the clue in the name. The activities performed in the monitoring and control phase are about just that. Analyzing the actual with the targets, so we can understand through numbers if something is not working fast enough or well enough. Everything we've done so far has been setting targets, the scope statement, the timelines, the budget plan, and the quality requirements. But we can't measure against targets if they're not measurable. In other words, we need metrics. Remember the defect rate for the production company we talked about in the quality section, where companies could set a 0.5% tolerance for defective products? That's a metric with a target. And the call center example, where a vendor would set a cases resolved target of 98%. That's a metric with a target too. Or how about a construction company that needs to meet preset safety regulations? That's right, these will be measured through metrics as well. Basically, every target needs to be measurable and comparable to the actual. Imagine each task as a long dark tunnel, and you are travelling down the tunnel with a carriage full of supplies that need to be delivered by 5 p.m. You can see the light at the end, but have no perception of how far down the tunnel you are. You don't want to unnecessarily drop supplies to increase your speed, nor do you want to be late. Monitoring and controlling the task not only lights up the tunnel, but also reveals a chart along the tunnel walls detailing exactly how far you are from the end. The only thing you have to do is use predictions, intuitions, calculations, and experience to determine if you are on target or need to drop some supplies to reach your objective on time. You will need to frequently collect data on your actual progress. It will be predominantly your job as project manager to do this. But, as with everything else, you can delegate this to workstream leaders as long as they update you regularly with the progress. Because, that's right, the project manager is the one accountable in the end. Right. Variances can occur in any part of the project, and it is how the project manager controls these variances that will make or break a project. So join us in the next few lessons where we will be discussing how a project manager can analyze and control each area of the project. Thanks for watching.
Section 12 and lecture number 53, how to check if a project is on schedule.
Let's start by looking at timelines. How can a project manager see if the project is running on time? Well, they should constantly observe the progress against the plan. After all, we didn't build the project plan, the Gantt chart, and the milestone table for decoration. They are super useful tools to measure actual progress with. Here is a small slice of our Gantt chart, and let's have a look at the status of these activities. We can see that the first one has been completed, as has the second and third. The fourth is in progress. We can see we're halfway through. However, the planning documents do not tell us if the actual progress is going at the rate fast enough to complete this on time. So, if a stakeholder asks if this task is on track, well, we don't really know. Yet. But once we learn about what PMI refer to as the schedule variance, that will change. Then we will be able to confidently answer any questions the stakeholder may have about the progress of a task. So, what is the formula for calculating the schedule variance? First, we need to know the planned value. This is the amount of work we plan to have been completed up to this point. For example, for the task Build Walls, there are 4 main walls to be built, meaning 1 wall every week. So at the halfway point, the planned value would be 2 walls complete and work on the third to start. Then we need to work out the earned value, which is the value of work completed to the present moment. In other words, the actual. So, as a forward-thinking project manager, you ask your chief engineer to complete reports each day on the progress of the construction. For the sake of simplicity, let's assume the main work is building 4 load-bearing walls. You have a target to create a wall every 2 weeks, 10 working days. You may see something like this. Cool. We can see wall 1 was completed on time, while wall 2 is at 80% completion. That makes our earned value 1.8 walls. So now, the formula to see if we're on track. The schedule variance is 1.8 minus 2, which equals negative 0.2. That's right, we're behind schedule, and if we don't catch up, this task will be delayed. But by how much exactly? Let's work out the pace of the work and how significant the delay will be using another tool from PMI, the Schedule Performance Index. The Schedule Performance Index is easy to use. We consider the same numbers as before, but this time divide, like this. If the Schedule Performance Index is lower than 1.0, it means there will be a delay. And if it's more than 1, then we're ahead of schedule. In our case, 1.8 divided by 2 equals 0.9, meaning if the team continue at the same rate, they will have completed 90% of the walls by the deadline. Therefore, we will need 10% more time. So, We work out 10% of the 20 working days in 4 weeks, being 2 additional working days needed to complete the task. Can you appreciate how useful this information is? Instead of reaching the deadline and seeing only 90% of the work completed and then relying on the buffer to do the rest, you have given yourself and the project team plenty of time to react. Either you find a solution to quicken the pace, maybe hire more staff or motivate the team, or at the very least, you can prepare the project for a delay by pushing other tasks back. But that's obviously not ideal. Next, we're going to look at controlling costs. Thanks for watching.
Section 12 and lecture number 54, how to see if a project is on budget.
So how does this all affect our cost? Will we complete the scope within the budget? Well, let's be proactive and find out, shall we? We know what planned value and earned value are. The value of the work planned and the value of the work completed, respectively. We calculate the cost variance to learn if we're on budget, and the cost performance index to learn if the rate of our spending will allow us to remain within budget for this activity and the project as a whole. So, first things first, let's transform our planned value and earned value into dollar amounts. Let's say the budget for the build walls activity is $200,000. This would mean each wall would cost $50,000, and our earned value so far is 1.8 walls. To convert this into dollars, we multiply it by the number of dollars, so 1.8 times 50,000 equals $90,000. We do the exact same thing for planned value. So 2.0 walls multiplied by 50,000 equals $100,000. Okay. Once we've calculated planned and earned value, we need to add the actual cost to the equation. Like the good project manager you are, you have been recording how much money has been spent up to this point. That said, it's time for a formula. The calculation for cost variance goes like this. You can see from your budget you have spent $83,000 on walls so far. So the formula would be earned value minus actual cost. So $90,000 minus $83,000, which equals $7,000. This is a positive number, which means we are doing better than planned and are under budget. As you can guess, if it was a negative number, the opposite would be true. So, while your team is behind schedule, they are spending less on the walls. Now, let's predict the future with the cost performance index. Once again, we divide. So it's earned value divided by actual cost. $90,000 divided by $83,000, which equals 1.08. Because the same rules apply, if the number is above 1, then we will be under budget if the work continues at the same rate of spending. If the number is below 1, then we expect to be over budget. Awesome stuff. With this information, we can see that we are behind on time but ahead on budget. And if you remember our triple constraint triangle, we've become a bit unbalanced. Even if we save money on the project but are over the deadline, then the project is still a failure. So you must focus on fixing the area where the problem lies. By performing these calculations, you can see that perhaps if you spend some of the extra money you saved and hire more labor, then you'll get the work back on schedule and balance out the triangle. Next lesson, we'll talk about controlling quality. We need to make sure that the output we're generating is to the standard we want. There's no point in saving money and time if what we produce is of the lowest quality. Thanks for watching.
Section 12 and lecture number 55, how to perform quality control.
Now we'll be looking at quality control. Quality standards vary more from project to project than time and cost, but we will highlight a few common things that you can do when performing quality control activities. So you have defined targets and requirements during quality planning, and you have collected actuals from the quality checks during execution. The same question needs to be asked again. Are the quality targets being met? The quality standards, targets, and how they are controlled will be very different from one project to the next, as is the scope. But as we said, we will highlight common things that need to be done in the control quality activities. We analyze quality on 3 different levels: input, process, and output. So how about an example? Imagine that your project was to cook a lasagna. You check your ingredients, decide on fresh or dried pasta and the beef percentage in the mincemeat. You follow all the steps during the preparation, preheating the oven, chopping the vegetables, and so on. Then you assess the completed dish. Is the bechamel sauce smooth, the pasta soft, and the cheese melted? These are your input checks, process checks, and output checks. Okay, let's look at this in more detail with our Lamborghini project. We start with input. This is when you need to get your work started on the right foot. If your resources aren't good enough to reach the desired scope, should you even start at all? Consider the construction materials for the building as an example. Here it would be sensible to give the responsibility of validating the materials to the owner of the construction workstream, as they are an expert in the field. While doing that, they will likely go through a checklist similar to this one. They will ensure all materials reach the necessary quality standards, either set internally or by safety regulations. A similar process will obviously take place in areas like car production and interiors, among others. Then comes quality control during the process. This is when you will need to ensure all steps are being carried out during an activity and no shortcuts are taken. In the hiring workstream, for example, if each salesperson knows everything about each car model and we decide to skip customer service training, then that knowledge will be useless, as our sales agents would not have the needed skills to actually make the sales. Again, delegating the responsibility to a member of the marketing team who keeps a checklist of all employees and the training they have taken will make the most sense. Finally, the quality control of the output. These are the quality checks at the completion point of a deliverable or activity. For instance, when the augmented reality effects on the cars have been finished, checks need to be made to ensure that they connect quickly with the electronic interface and that inputs are responsive. If the target is for the effects to happen in under 3 seconds, is that criteria met at least 9 times out of 10? Awesome. No formulas for this one. But the core of this type of control is still comparing the actuals to the measurable targets you set during the planning. Remember though, that you, as project manager, are not the final point of contact when it comes to quality checks. Many deliverables will need to be approved by the project stakeholders and especially the project client. Lamborghini are notoriously careful when it comes to their safety and emissions checks on cars, especially since the Volkswagen emissions scandal in 2015. They will not approve the project if this quality criteria is not met, as just one example. Quality is as important as time, cost, and scope are when it comes to project planning. Without quality checks being signed off, the project is at a huge risk. Promising a car in 3 months for $100,000 that accelerates from 0 to 100 in 3 seconds, and delivering a car in 3 months for $100,000 that accelerates from 0 to 100 in 7 seconds is not a successful project. The triple constraint triangle is just as affected by quality also. Increasing the quality requirements will take more time and resources, and vice versa. Excellent. We discussed some ways to control quality. So let's jump into another big part of our project, the risks. Obviously, risks themselves can't be controlled, but how we deal with them can be. Well, you'll see in the next lesson.
Section 12 and lecture number 56, how to keep the risk log updated.
An inherent quality of risks is that you can't control them. Otherwise, they wouldn't really be risks, they would be events that you prevented from happening. So when it comes to controlling risks, it's more about controlling their evolution and ensuring that you as project manager are always prepared. The first thing you can do is keep the risk log updated. As the activities are completed, the risks surrounding them are no longer an issue and can be closed. In our log, when construction is finished, we can do this with risks 1 and 2. In addition, the severity and probability of a risk can change as the project develops, and this must be regularly updated. If a risk is starting to look like it may become reality, then you have to start preparing for your contingency plan. And one last important thing about risks is that you need to keep an eye out for any new ones that may arise and record them as you have done with the others. As project manager, you need to be one step ahead of risks. Expect the best, prepare for the worst, and no risks will sneak up on you and take you by surprise. Next lesson, we'll talk about how to control changes. Rarely a project is executed without some deviation to the plan. So, let's see how a project manager could deal with that.
Section 12 and lecture number 57, How to Deal with Change Proposals.
We discussed the change process during the planning part of this course. But as you may have picked up already, you can't plan for changes to the project, you can only prepare for them. So what really happens when a change request is submitted? Let's look at an example in our Lamborghini project. Imagine you're 4 months into the project and are faced with 3 situations. First, the software engineer responsible for the visualizations on the podiums contacts you saying that it will be easier for her to install the projectors if you modify the roof. The roof has already been built and changes would cost $10,000 and take an additional 2 weeks. After that, the marketing expert in charge of training the new staff explains to you that important training needs to be added to the training program at the cost of 3 more days and $1,000. And just when you thought the day was over, the car producers call to tell you that instead of transporting all the cars on the agreed date, they will only deliver half and the other half the following day. Whew, what a day. So, what would you do? Which would you say yes to? And what additional questions will you need to answer before making a decision? On one hand, you're very aware that any changes will cost time and resources, and of course you put so much effort into planning you want to protect that plan. But on the other hand, as work progresses, better ways to do things will come to light. Maybe something had been missed during planning, or perhaps someone just came up with a new idea. Not all changes are bad, and some are just necessary. It's up to you to differentiate between them. The best way to do this is to be vigilant in your approach. The brief overview of a change process looks like this. Get as many details as possible and gain an understanding of what impact the change will have on the scope, time, and cost. Once that is clear, you can decide to reject the unnecessary changes or those that increase the scope, time, or cost more than they're worth. You can take suggestions through the change process. Prepare a change request form with all the appropriate information and obtain approval from the project sponsor. Or, if the changes are of low impact on the time, scope, and cost, you can implement them without the lengthy approval process. Awesome. So let's see how you could handle the previous situations. With the software engineer's proposal, it would be a sensible idea to reject it. There isn't much that would benefit the project. It may make the software team's job easier, but their responsibilities would have been detailed in the project scope and their roles agreed upon previously. Of course, you would need to ask plenty of questions. You will need to speak to engineers to make sure the planned work can actually be done and it isn't a problem that was unforeseen. You may even find a compromise that would not cost the project as much work. You are a reasonable project manager after all. With the marketing expert's suggestion, you will need to investigate to see if the training is in fact relevant for the staff, and if so, establish whether triggering a change will cost the project or fall within the buffers you gave the task. If all is well, you would likely start prepping a change request form. As for the car production, this seems like a minor change. One day is not going to make a difference to the project, so you could just agree and update the plan accordingly. Of course, you will want to get more details to ensure that this delay is not being caused by a bigger problem with production and that quality is not being compromised. You are a great project manager, so you will not want to agree to anything blindly. Cool, you handled that very well and with minimal cost to the project. Well done. And with that, we have covered how to control your project. You learned how to read the actuals and measure them against the targets in your plan. You also learned how to use this information to tell you if you can complete a task on time, on budget, or both. You know how to measure quality at each stage, and you can keep your risk assessment up to date. Finally, you learned how to confidently deal with any potential changes in your project. You must be good at juggling to handle all of this while executing the project at the same time. Speaking of which, let's head back to execution and see how to keep the stakeholders updated with your project. Great work, everyone.